Let's look at another example of Exo Trig. Here, it's the lone pair on the alcoholic oxygen, oxygen 1, that attacks the alkene at carbon 5. As a result, we form a 5-membered ring. Now, let's cautiously think about the reaction a little bit more. Maybe the double bond between carbon 4 and carbon 5 breaks to become a single bond. Now, carbon 4 and carbon 5 are part of the new ring that forms, and so the double bond that breaks is an internal bond. We describe this as endo. When we look at carbon 5, we know it's part of a double bond, and so this is trigonal in nature, or trig. So, immediately we should be concerned here. Baldwin's rules say that this reaction is unfavored. Now, we've seen cases where, according to Baldwin's rules, something is unfavored, but still it happens in real life. But you should always be concerned when Baldwin's rules say this shouldn't be happening. And in this example, you would have every reason to follow the concern expressed by Baldwin's rules. The reaction here is in fact not 5-endo trig. So, what's going on? Well, an important part is different. If we look at the methoxy group on the phenyl ring, it seems that's miles away from the key area of the molecule and shouldn't be involved in the reaction, when in fact it plays a critical role in the reaction. It's the lone pair on the methoxy oxygen that indirectly attacks the acidified water through the conjugation that's within the molecule. This sets us up for a molecule that can then cyclize. But this molecule has a very important difference from the 5-endo trig we were just looking at. We're still cyclizing to form a 5-membered ring, so that's the same. We are still attacking with the lone pair of the alcoholic oxygen on oxygen 1 to carbon 5 that is an alkene. So carbon 5 is trigonal. So 5-membered ring, trig, those two are the same. Here comes the important difference. The double bond we're looking at breaking is between carbon 5 and one of the carbons of the phenyl ring. The phenyl ring is not part of the new ring that's forming, and so this bond that breaks is evaluated as being external. We call this exo. From the ring that forms, we then deprotonate to arrive at our final product. But what really happens here is 5-exo trig. And we know from Baldwin's rules that this is a favored reaction. Just goes to show you that Baldwin's rules can be very helpful to tell you to be cautious in some cases. Sometimes it's not the obvious thing that does actually happen.